All right, class, go ahead and get started. And if you would turn in your books to page 12 squared, we're going to take a look at your homework. Read the first three prime numbers in the review section, 2, 3, and 5. They're page 12 squared. That's page 144 for you, Bracken. Page 144, you did the review numbers. I got goofy people in my class and I go along with them. I don't know why. Because they bring me presents. By the way, don't forget, cash gifts, PayPal. All right.
What's your PayPal? What's your cash app? What's your Venmo?
Christmas tree cakes.
All right, Christmas tree cakes, but don't mail them. They'll be moldy, Gavin, by the time they get here. Brecken, you can hand deliver Christmas tree cakes. I'll even give you free tutoring if you brought me Christmas tree cakes, just saying. All right, though, by the time you watch this, if you're still finding Christmas tree cakes, I don't know how old they are. Page 144. You did the review, numbers 2, 3, 5, 10, 12, 14, 15. Let's go over those first. And number 2 was an equation with a radical in it. And we call this a radical equation because it has a radical in it. And what's the key to solving radical equations, class? 2 steps?
Isolate.
Radical square. Okay. So Abby even has the right tone of voice. So Abby, nice and loud for the camera. Do it again.
Isolate the radical, square both sides.
You seem more sing-songy, like isolate the radical, square both sides. Like I thought you had more of a sing-song there in your voice, but yeah. And it should just be that well memorized. You say it half asleep. Isolate the radical, square both sides. It's already isolated. We square both sides. What do we get when we square a square root, class? The radicand. 8x plus 12. What do we get when we square a binomial, class? Perfect square trinomial. How do we square a binomial, class?
Square the first, square the last, multiply and double.
And so we should square the first, square the last, multiply and double. How many have this as your first step on? Number 2 from the homework. All right, so quadratic all of a sudden. So we're going to set it equal to 0. Also, variable inside, variable outside. I could have extraneous roots here, so we want to be careful with that. I'm going to keep the x squared, bring the 8x over s as a negative 8x, but that combines with the 6x to get. And then bring the positive 12 over as a to get. And then, of course, we'll want to backwards FOIL x negative 3x positive 1 should be how we factor it to get what two possible roots to the equation, class?
3 and negative 1.
Positive 3 and negative 1. But one or both of them, probably just one of them, could be extraneous. Maybe neither of them, but possibly. So let's try the 3 first. When we 3 plus 3 is 6. Okay, 8 times 3 plus 12. Square root of 36 is. All right, so the 3 checks out. Let's try the negative 1. Negative 1 plus 3, 2. All right, 8 times negative 1 plus 12. Positive 4. Square root of 4 is 2. 2 equals 2? No. Extraneous roots this time. You won't always have them, but we got to check. How many had those 2 roots for number 2? All right. Question. How far did we make it before things kind of fell off?
When I brought the 8 over, I added it.
To get 14x? Okay, gotcha. All right, so be careful there. Number 3, we have 2 radicals. This is also a time when we would need to check our solution to make sure we didn't mess something up here. And in this case, isolate the radical. Well, there's 2 of them. Normally, I'd say, class, isolate the biggest radical, but they're really kind of equal, so just pick one already, right? Let's ditch one of these 2 radicals, and Maddie, who do we kick out? You can't say bracket. Pick one of the... I'm just kidding. She said square root of x negative 2. So we're going to kick this out, and we're going to say the square root of x plus 7 equals 3 minus the square root of x negative 2. I say he's already gone. I already got rid of him, all right? Just kidding, Bracken. Just kidding. All right, we miss you. We really do. I miss seeing your reaction when I pick on you. I can't see it anymore. I just have to envision it. I just think back in my memory to all the times I did it last year. It was great. All right, so we kick it out over here. I can just turn it off. And so now we've isolated one of the radicals, class. Now we will square both sides. And so we square, square root. We get the, which is, here we got to square the first, square the last, and x negative 2, and that is a positive x negative 2. And then we've got to multiply these 2 terms and double to get what, Genesis?
9.
Well, multiplying double, not multiplying square. 3 times 1 doubled gives you not 9, but 6.
Times x, the square root of x minus 2.
There we go. And what sign are we going to have right here? The negative. There we go. All right, at this point, the x and the other x conveniently cancel. By the way, 9 minus 2, class, equals 7, but there's a 7 over here. So that 7 cancels with these, and all I'm left with is nothing equals negative 6 times the square root of x minus 2. Thoughts at this point? What should we do now, Michael?
You should divide away 6.
And 0 divided by anything is still
0.
So it's still just 0 equals the square root of x minus 2. And now we've isolated this radical. So we isolated one of the radicals, squared both sides. That still leaves us with a radical because of the multiplying double. Isolate that radical, and now once again, class, square both sides. But 0 squared, 0 equals x minus 2. So obviously x can only equal 2. Let's see if it checks. 2 plus 7, square root of 9 is 3. 2 minus 2, square root of 0. 3 plus nothing is 3. And it checks out. No extraneous roots here either. How many got 2 for your answer on number 3? How many, when this side canceled to nothingness, you were concerned that you've done something wrong? Good. All right, you have more confidence in yourself than that. Excellent. Let's take a look at number 5 now. And this equation is not a quadratic. It's a quartic, but it's in quadratic form. So we can solve it like a quadratic. We set it equal to 0, which they already did for us. And then, class, we
Foil. Backwards foil.
factor, backwards foil. And when we factor it, what do we get, Audrey?
X squared. X squared. Negative. 3. No, that's not right.
Don't do 3 and 8, okay?
4 and 6.
Let's do 4 and 6 instead. I like that better, okay? And once we set we factored it, then we need to set each factor, Abby, equal to,
Equal to 0.
and that'll give us 2 little mini quadratics. Each of them is incomplete.
X squared equals 4 and 6.
And so for these incomplete quadratics, we isolate the x squared, and then in class we just take the square root of both sides. And here, what are my answers going to be, Genesis?
X equals square root of 6.
Minus a point.
Positive.
Positive, negative on both of them. There we go. And there's my 4 answers. 2 real, 2 real rational roots, 2 irrational real roots. Questions on these? How many had those answers, first of all? All right, any questions on 5?
I forgot to factor x squared.
Okay. So you had 4 and 6 as your answers. All right, careful there. Number 10 was our next one, where we had an x negative 5 raised to the 2/3 power equal to 9. What are we going to have to do here, Michael?
Multiply it by the 3/2. You square it by 3/2.
Raise it to that power. When you say square, you mean raise to a power, right? We're going to raise to the 3/2 power, as he said, the reciprocal power, right? Because when you raise to the reciprocal power, you're multiplying the exponents. And when you multiply by a reciprocal, they cancel. I'm just left with x negative 5. But over here, how should we read 9 to the 3/2 power? What are we actually doing?
Square root of 9 cubed.
Square root of 9 cubed. But what are the square roots of 9?
Positive negative 3.
And when you cube positive and negative 3, you get...
Positive negative 27.
From here, we need to add the 5 to the other side to get...
32 and negative 22.
Excellent. There are my 2 roots. Cool. How many had those answers? First of all, on number 10, questions. Let's take a look at number 12. Very similar problem. We have an x plus 10 to the 3/2 is equal to 125. And Maddie, what do we do? Good. Raise to the 2/3 power. And of course the 2/3 power and the 3/2 power to give me. And on the other side, again, 2/3 power really means what here? Good. How many cube roots of 125 are there? How many cube roots? Like for instance, we take the square root of 9. There's 2 square roots. How many cube roots of 125 are there? Technically 3, but 2 of them are complex. So I said don't worry about them. So 1 real root, right? And that's 5, which you already said. And then we square the 5, we just get. Again, no positive negative needed for the odd root, remember. And then we just subtract away the 10, and we get 15 for our answer. How many had that on number 12? Questions on that? You threw me off for a second there, Genesis, with the thing across the mouth. I was like, how did I not notice it? It's just a necklace. We're good. All right, number 14. We have an absolute value problem, and really straightforward. Remember, the key to absolute value class is to isolate the absolute value and then set it to positive, negative, whatever's on the other side. So in the case of number 14, my two equations are just going to be that x minus 2 equals 125 and x minus 2 equals negative 125. In each case, we add the two, and really straightforward. What two answers do we get, Audrey?
123 and my brain is
125 plus 2?
27.
127, and then here add the 2 to the negative 125, get negative 123. How many have these answers for number 14? Number 15, on the other hand, not quite as straightforward because we have a polynomial on the other side. So when we set it equal to both positive and negative whatever, my equations are going to be a little bit longer here. Abby?
You x squared minus 5x equals 4x minus 20, and x squared minus 5x equals negative 4x plus 20.
Excellent job. From here, we have two quadratics. Set them both equal to 0, and we'll solve from there. Let's go and set this one equal to 0, Abby.
X squared minus 9x plus 20.
And then over here, Genesis,
X squared negative x positive 20.
well, it comes over and becomes negative 20. There we go. So we'll backwards FOIL in each case, or factor each case. Here, x and x signs class are both going to be negative, and we should factor the 20 into 5 and 4 over here. X and x signs this time class alternating different, and then the 20 should split into 4 and 5, so that the 5 is the negative to get the negative 1x. When we set each of these factors equal to 0, and it with x could equal 5,
negative and positive
4,
negative 4
or positive 5, which is coincident with an answer we already have. Remember, the easiest way to check an absolute value is to make sure that whatever winds up over here is a positive value. Well, if I plug in a 5, class, that makes this minus 20 equals, that could work. Let's see if it works over here. Square the 5,
25
and 5 times 5, 25 minus 25, 0. So yeah, that one checks out. If I plug in a 4 right here, 4 times 4, class, 16 minus 20, I already know absolute value is not going to give me a negative. If I plug in a negative 4 times 4, no, 16, negative 16, negative 20, negative 36. Yeah, that also can't possibly work. So rather than even taking the time to plug it in over here, just by testing it there, save myself some time. X is only equal to 5. How many had that on 15? Questions on any of the review part of the homework? All right, well, let's take a look then at the new stuff we were looking at in our last lesson. And those were the quadratic inequalities. Remember, an inequality solves just like an equation, except for a small difference. Usually the small difference is if you divide by a negative or multiply both sides by a negative, you're going to flip the inequality. In a quadratic, though, it really solves just the same as a quadratic equation. Set it to 0, set the factors to 0, and solve. But when you get your answers, they're not answers at all, class. They are separator points, good, that divide the whole number line into different areas, different ranges of values. And so we get our separator points, we look at those different ranges of values, and we pick a not-so-random value from each of those ranges. The more random it is, the harder our life is. And I don't like a hard life because I am lazy, yes. And so we also began looking at higher power inequalities as well. For instance, 19 isn't actually a quadratic at all. It's a cubic. So we're expecting how many separator points, class? 3 separator points, which is going to give me how many ranges of values on the number line? 4. Very good. Go back to sleep, Michael. All right, I'm just kidding. All right, so if this could factor by grouping, I'm all in. That's my preference. I'd always rather factor by grouping, but we can tell by looking at the numbers, class. No. Usually I just kind of look at the last group. Is there anything I can do with that? Nope. Well, we're done. All right, so we're going to do the P over Q thing, right? But when we do the P over Q thing, remember, my possible rational roots, or separator points in this case, positive -1, positive -2, positive -5, positive -10. Well, obviously I'm going to start with
Plus 1.
1. Now let's see if it works. If I plug it, that's not what it is. If I plug in a 1, class, I get
1 minus 4 minus 7 plus 5.
equals 0, yes or no? And once again, they were really nice to you. By the way, the fullness of the stocking is directly proportional to my niceness on exam day. I did think I'd mention that. And Michael has made some good contributions, and Genesis has made good contributions to the stocking. There might be multiple versions of this exam. You just know. I'm just kidding. I'm not going to make it harder just because you don't put anything in my Christmas stocking. Anyway, but they were awfully nice to you, right? And so they give you a 1 that works out, which means one of my factors, class, is
X minus 1.
k negative 1, right? That's one of my factors, but the root is a positive 1. So we're going to divide out that root, remember, and we'll bring down the 1, and then, class, we multiply to get,
1,
and then we add to get,
-2,
and we multiply to get,
-3,
and we add to get,
-2,
and we multiply to get,
-3.
and we add to get, and that's a really good sign, because if you don't get a 0, you screwed something up. And so we're going to fill in the gaps, remember, with the k squared and the k to the first and the k gone. And the goal is that when you get to this point, you could factor it. Now, what if you couldn't factor? I mean, besides that sad, weeping, wailing, gnashing of teeth, what would you have to do if it didn't factor? Formula or complete the square, but in a lot of cases, complete the square is going to be out, so formula ends up coming into play. Here it doesn't, though. This factor's just fine. Class k and k,
-5.
negative positive, and we said -5 and positive 2. All right, so if those are my factors, what are my separator points?
Positive 1, positive 5, -2.
Positive 1, positive 5, and -2. And again, I recommend drawing the number line. Here we've got a, let's see, that's going to be solid dots here. 1, 5, and -2, my separator points. By the way, don't get 0 mixed up for a separator point. I like to draw it for reference. But 4 ranges of values. What's the first range of possible values here?
-infinity, -2.
What about the next range here? Genesis?
-2.
-2 and 0.
Well, careful, not -2 to 0. My next separator point is the 1. Again, that is the downside of putting the 0 on the number line. The next range?
-1 and 5.
And then the final range.
5 and infinity.
I want to pick a number in each of these ranges that will be somewhat easy to plug back into the inequality. So, Abby, give me my test points.
-3, 0, 2, and 6.
All right. All right, let's start with 0. Bam, bam, bam. 10 is less than 0, class?
No.
Now, I could go alternates or I could go inside, outside. Let's try the 2 next. If I cube the 2, class, 8. Square it times 4.
16.
2 times the -7. Plus 10 is less than or equal to 0.
Yes.
Yes, comes out negative. So the 2 checks out. So it can't be insides, outsides. It's got to be alternate. So which range do I expect to work here, Genesis? Now that I know that of the 1, 2, 3, 4 ranges, the third range works, the second one doesn't. I now expect...
Inside.
Well, it can't be insides work, outsides don't, because one inside does and one inside doesn't, right? So it can't be that. It's got to be the alternate pattern. So we're expecting which range to work. The pattern is it works, it doesn't work. So what should this one work? Or yes or no? If it alternates, works, doesn't work, works, and when we'd expect this one to be work, no, yes, no. Does that kind of get the idea of yes, no, yes, no? So I'm expecting probably this will, probably this won't. Just to test my theory, we've got to test one of those two. One's negative, which I don't like, but one has a 6, which is big, and I don't like that either. So let's try...
6.
Okay, Michael wants the 6. Keep the 6, Michael.
That's a lot.
We memorized this one.
I forget a
This
lot.
wasn't the hard part.
216.
216. And then we square the 6
36.
times negative 4.
Negative 134.
And then the 6 times the negative 7.
42.
Negative 42. Plus the 10 is less than or equal to 0. Yes or no?
No.
No, which we expected it not to. Which means this one must, so we can get the yes, no, that alternating pattern. How many have these answers on number 19? Questions on 19. The other option is you don't have to worry about patterns, you just test all 4 of them. But again, patterns make our lives easier. Let's take a look at number 22 next, and this one's a little bit weird. We got a 2y to the 4th minus 4y cubed, negative 70y squared, all less than 0. What can I do to make my life just a little bit easier here? Maddie? Now let's factor out the 2y squared, and that's going to give me something much more easily factored. Yeah, and that factors really easily into good y plus the 5y minus the 7. And so when I set each factor equal to 0, here, what is y equal to? Positive negative 0, which is just 0, right? And though technically 0 and 0 are 2 points here. And then, so when we look at our number line here, this time 0 is one of the separator points. But we have open circles, right? So 0 to 0 is one range, but you can't include 0 or 0. So class thoughts?
No.
Yeah, this one definitely is not going to work anyway. The next one would be a 7, and the next one would be a negative 5. So my first range, negative infinity to negative 5, negative 5 up to the 0, 0 to the 7, and then 7 to infinity. We already know the 0 isn't going to work. So let's pick some numbers here, and this time we'll let Michael pick something smaller than negative 5.
Negative 10.
Something between negative 5 and 0.
Negative 3.
Okay, something for negative 1. Something between 0 and 7.
2.
And something bigger than 7.
23.
All right, so let's start with 2, all right, of the numbers he picked, and 2 to the 4th class.
Wait, could I have chosen 0?
No, because 0 is already arranged into itself that we discounted. But yeah, 0 is a great number to pick if it's available. So is 1 and negative 1. They're great numbers. But we'll try 2, class. 2 to the 4th. 16 times 2? 32. 2 cubed times negative 4.
32.
And then 2 squared. 4 times negative 70. Negative big, right? Negative 280. And of course, the 32 and negative 32 cancel, so we get negative 280 smaller than 0?
Yes.
Absolutely. Genesis, do you need to stand behind the camera? You sure? Okay, you just seem like you're drifting on me there. You're tired from the weekend. Let's try negative 3. Raise negative 3 to the 4th class. You know, I'm gonna go against Michael. I'm gonna call it a negative 2 because this is gonna stay a 32. It's gonna change to a positive 32. It's gonna stay a negative 280. Okay, so I'm gonna cheat the system a little bit there. All right, is that less than 0?
Yes.
It still is, even though these don't cancel. It's still considerably less than 0. So this range works. So it looks like insides work, outsides don't is kind of what we've got going here. Let's try a negative 10. You raise that to the 4th, and that's what? Negative 10,000 or positive 10,000?
A big number.
Times 2 is positive 20,000. The problem is this is also a big number. You cube a negative 10 class.
Negative 10.
Negative 1,000 times negative 4 is positive 4,000. And then negative 10 when you square it, 100 times negative 70 gives us negative 7,000. Is that smaller than 0? No. What if we ignored Michael again, and which is getting easier to do, and we try a positive 10 instead? Well, this is going to stay the same. This is going to become a negative, and that's going to stay the same. Is that smaller than 0? No, still negative. That doesn't work. So we end up with these two ranges, basically negative 5 to 7, but not the 0 that's in the middle. So negative 5 to 0, 0 to 7. How many have these answers on 22? Okay, only a couple of questions. The hard part, of course, is all the test values, and this is why you're really thankful you have a calculator. Right? Though it's faster if you can do it in your head more often than not. All right, number 23, the last thing from our homework, and then we are going to change gears. You will practice with this in your homework tonight a little bit more, but we're going to change gears after this, because I feel like we are ready to be done with these for a little while, at least till tonight's homework. Number 23, I got an m to the 4th positive 10m cubed positive 21m squared less than or equal to 0. Genesis, what do I do?
I'm still
Good.
m squared plus 20 plus 10. And then m plus 7 m plus 3.
All right, and that's going to give us, when we set each of these to 0, it's going to give us what values?
-7, -3, and m squared.
We'll take the square root of both sides. We get
M
0 and 0. Right, positive, negative, 0. There's two zeros in there because it's m squared. By the way, if this is just m to the first class, it's just a single 0. 0 doesn't get arranged into itself, but because it's an m squared, there's two different zeros here, which is why 0 to 0 gets its own range. So closed dots this time. So closed dot at 0, another closed dot at 0, a closed dot at -3, and a closed dot at -7. So we've got negative infinity to -7, -7 to -3, -3 to 0, and 0 to infinity. 5 little ranges here. Okay, well, let's test the 0 and see if it works. Well, nothing plus nothing plus nothing is less than or equal to 0. Yeah, and anytime we got the brackets, you know the 0 itself is going to check. Let's pick something bigger than 0, class. Thank you, Audrey. New favorite student, even though you didn't put as much in my stocking. All right. By the way, who made the cookie anyway?
We did.
We collectively, it's just we
Yeah.
chemistry
I
class.
wrapped it.
You wrapped it. She wrapped it in the used.
We made it with love.
Yeah, we did. Yes.
Ah, there he is. Good to see you,
Yes.
Brandon. You'll want to watch the first 27 and a half minutes. Well, first 27 minutes. Last 30 seconds you have to watch. The first 27 minutes of the lesson. So let's try the 1. Class, if you plug in a 1, this becomes 1. This becomes, and this becomes 21. And when you add those all together, do you get something smaller than 0? No. Anything positive is going to come out bigger than 0, so we can't have anything positive. All right, let's try something smaller than 0, but still in that, but bigger than -3.
-1.
I like -1. Thank you, Abby. And so we, okay, also favorite student. All right, so to the 4th is still just
Positive
1. This becomes
Negative
-10, but this stays
positive
21. So 1 minus 10 plus 21, that's still too big. So this, gone. Almost looks like we're alternating here, doesn't it? So let's pick something between -7 and -3.
-4.
All right, get in there with the quick answer. Let's do to the 4th power. You memorized it. 256. All right, cube it. -64 times 10 is -640, and then square it.
16.
Calculators times 21. 336? All right. But 256 and 336 added together is still smaller than the 640 in absolute value. So the negative still wins. Negative is smaller than 0. That range wins. All right, so it looks like we're alternating here, doesn't it? No, yes, no, yes. I'm expecting this to be a no. Massive.
Can we just say no?
This is going to match if you strategically pick the 10, right? Because 10 cubed times another 10 is the same as the 10 to the 4th. But this will be negative, this will be positive, they cancel. Square becomes positive times 21 positive. It's definitely a no. So my ranges are -7 to -3 and 0. And there we go. How many had that for number 23? All right, questions on 23? Any questions on the homework? All right, like I say, you'll do a little bit of practice with this tonight in the homework. For now, let's talk about rational inequalities. Talk about quadratic inequalities. Let's talk about rational inequalities. Anytime we mention rational, class, we're referring to fractions. Yeah, so inequalities with fractions in them. Step number 1, set the entire expression to 0. Set the entire expression to 0. Now notice I didn't say equal to 0. Of course, these are inequalities, but set them to 0. Step number 2, get a common denominator. Get a common denominator and simplify to one fraction. So you may have multiple fractions in the inequality, but I just want one fraction by the time it's all said and done. Step number 3, set the numerator equal to 0 to get critical points. Set the numerator equal to 0 to get critical points. Number 4, set the denominator equal to 0 to get critical points. But there's a little caveat with the denominator. Is the denominator of a fraction ever allowed to equal 0, class? No, that is the one thing to which a denominator may not be equal. So you're going to set it equal to 0, but regardless of what sign you use, you're always going to use an open dot on this particular value. Here, if it's greater than or equal to, closed dot. Less than or equal to, closed dot. Here, I don't care what the inequality symbol is. If it's a denominator critical point, always gets an open dot, because the denominator can never actually equal 0. Here, the numerator could if you had the less than or equal to or greater than or equal to. So one little caveat there. And then, of course, as we would expect, once we've got these critical points, that gives us ranges, we've got to use our test values. So the final steps are going to seem very similar to what we were just doing. The real difference is getting the critical points at all. It comes from setting the fraction, or getting a single fraction in our rational expression. It would not come out. Getting a single fraction unequal to 0, and then getting our critical points, some from the numerator, some from the denominator. Let's start with a really easy one. Write this down. X plus 3 over x minus 1 is greater than 0. Notice it's already set to 0. Notice we already have a common denominator because it's already simplified to a single fraction. So we're going to set the numerator equal to 0 to get critical points. What's the critical point from the numerator, class? Negative 3. And then we're going to set the denominator equal to 0 to get a critical point of positive 1. Now, this is always open dot, open circle. In this particular case, the numerator, class, also gets the open dot. But if you had an or equal to, it'd be a closed dot. So both of these on the number line are going to be open dot. So 0, 1, negative 3, 2 dots. How many ranges? 3. Negative infinity to negative 3. Negative 3 to 1. 1 to infinity. Does that make sense? And now we just test them just like we were just doing. So we pick a not so random value between negative 3 or negative infinity and negative 3.
4.
Negative 4. We pick something between negative 3 and 1.
0.
And something between 1 and infinity.
2.
Let's start with 0. Is that greater than 0? No. So that's -3. It's not bigger than 0. This ranges out. All right, let's try the 2. 2 plus 3, 2 minus 1. Is 5 over 1 greater than 0? Yeah. Let's try -4. -4 plus 3. And then -4 minus 1. -1 over -5, what happens to two negatives? Cancel. Is 1/5 bigger than 0? Yes. For instance, if there were, a cheesecake or something, and somebody said, "Would you like to have a fifth of this cheesecake, Mr. Nadasky?" If it was one of you, I'd be a little suspicious. Be like, "All right, did somebody already take a bite of this?" And but if it was like a perfect piece of cheesecake, no germs or anything, no former fruit roll-up wrappers have touched it, then maybe a fifth is better than nothing, right? If you can I have cheesecake? No. Versus here, you can have a fifth of the cheesecake. See, that's bigger than 0. So this works as well. I'm done. There's my answers. Questions on this? Seem pretty easy? All right, let's do another one. Write this one down if you would, please. 3 over x negative 2 is less than or equal to x. Here we're going to have to do the whole process. Start in class by setting it to 0, which means we have to move the x over as a negative. And I'm going to put it over 1. I would recommend taking things that aren't fractions and putting them over 1 so we can see them in their fractional state. Now we've got it to 0. Not equal to 0, but less than or equal to 0. I'm going to look at my denominators. I've got an x negative 2, I've got a 1. What's the LCD? X negative 2. So I'm going to draw a long line. I'm going to put x negative 2 below it. Here, I have a denominator of x minus 2. What do I have to do to change that into an x minus 2? Nothing. So what do I have to do to the 3? Nothing. Just bring it down. What do I have to do to a 1 to turn it into an x negative 2? Multiply by x negative 2. So what do I have to do to the top? And here, notice it is a negative x being multiplied by x negative 2 to get what, anyone? Interesting dynamic I just observed. Abby has been answering everything this whole time with a little echo from the class. As soon as Brandon shows up, Brandon just takes charge. And Abby's just quietly sits there while he does the answering. All right, I hadn't really noticed that before, but since he was gone, it came in. Interesting dynamic there. And Abby's never again. All right. Steeled her with resolve. All right. So now we have one fraction. Make sense? Once you get to a single fraction, now it's time to set the numerator, first of all, equal to 0. Well, if I set it equal to 0, though, thoughts on this numerator thing, class? It's quadratic, and it's set equal to 0, but I really want the x squared to be positive. So let's rearrange a little bit here. Let's bring everything over and switch the side. Make this the 0. So bring everything over to get. All right. Everyone follow what's happening here? Any questions? All right. And then when we factor this, x minus 3x plus 1, my numerator gets me 2 critical points. 3 and -1. My denominator, when I set that equal to 0, gives me just a single critical point, 2. Now, as we look at the original inequality here, I've got the or equal to, which means my critical points should be open circles or closed dots? Closed. And that's going to be true of the 3 and of the -1. But denominator, we said, always has open circle or open dot. So I'm going to have 3 critical points, 2 closed, 1 open. Y'all following? Any questions before we get to the number line? All right. Here comes the fun part. All right, so here's my 0. All right, so 3 gets a solid dot, -1 gets a solid dot, and 2 gets the open circle. 3 points, how many ranges? 4 different ranges. -infinity to -1. Notice parenthesis, of course, on the -infinity, bracket on the -1. Then we're going to go -1 to 2, bracket on the -1, but parenthesis on the 2. The next range is really obnoxious, 2 to 3. Small little range there. And then finally, 3 to infinity. Questions on setting up the possible ranges? All right, well, I'm going to start right here with my 0 test value. If I plug in a 0 here and here, that says that 3 over negative 2 is less than or equal to 0. Is that true? Yes. Negative something is positive divided by negative is negative is always less than 0. So this range works. Let's pick something bigger than 3. 4, thank you. All right, so 4 minus 2, of course, is just 2. So 3 over 2 is less than or equal to 4. Is 3 halves less than 4?
Yes.
It is. All right, so that one checks out also. It looks then like we've got alternate ranges working, right? As opposed to outers and inners, it's alternates. So I should not expect this bottom range to work. Notice I'm avoiding the fraction that I would have to do if I did something between 2 and 3. Let's try a value smaller than negative 1. I don't know why my 0 was so weak and everything else was stronger. If I plug in a negative 2 here, class, negative 4. So get 3 over negative 4 is less than or equal to negative 2. Is negative 3/4 smaller than negative 2? No. This does not work, and that practically confirms that this does not work, which is really happy for me because I didn't want to have to plug in a 2.5. And there we go. Questions on this one? All right, we following what's going on? All right, let me have you try one of these at your seats, and on page 149. Page 149, I want you to do number 7. Page 149, number 7. If you're finished, go on to number 9. If you finished and got it, go on to number 9. If you have questions, now's the time to ask. I'm not OCD or anything. Any questions on 7? Anyone need more time on 7? I'm working on 9. All right, check your answer to 9. And any questions on 9? Any questions on rational inequalities? Getting some questioning looks still. We're good? All right, homework this evening, you're going to try a few of these. First of all, on page 149 at the bottom, I want you to do the review, numbers 10, 12, and 13. Page 151 at the top of the page, I want you to do number 19. And then on page 149 in the practice, you're going to do 1, 2, and 6. All right, so 7 inequalities for you to solve this evening. We'll take a look at those in our next lesson. Have a wonderful rest of your day, and you are dismissed.